Creation of the largest map yet of the invisible material that helps make up the universe, what's known as dark matter. Jeffrey Brown explores some of the very cosmic questions around this story.
That's worth saying again. We can't see it, but we can apparently map it. What's called dark matter is in fact everywhere, and it's believed to play a crucial role in forming and holding together galaxies with its gravitational pull. In findings announced Monday, researchers used a dark energy camera and a large telescope in northern Chile to create this color-coded map, showing a small piece of the visible sky. Orange and red areas represent denser concentrations of dark matter. Blue areas are less dense. And Sean Carroll joins us now to tell us all about it. He's a cosmologist and theoretical physicist at the California Institute of Technology. Thanks so much for joining us and helping us here. Can we start with a basic question? What is dark matter?
Sure. Dark matter is some kind of particle. It's just just like ordinary matter. You and I are made of atoms. There's some other kind of particle, not anything we find in atoms, not anything we've ever found here on Earth. It's dark, it's invisible, but it's most of the matter in the universe.
So how do we know it exists?
Well, because of gravity. Gravity is universal. Everything that exists creates gravity and is affected by gravity. So the dark matter, which is most of the matter in the universe, creates a lot of gravity, and then it pushes around things in the universe, including the light from distant galaxies as they pass by the dark matter concentrations.
And I referred to it as sort of somehow holding together galaxies. That's through its gravitational pull?
Well, that's right. Even without dark matter, the galaxies would still be held together, but they'd be moving much more slowly. The stronger gravitational field controlled by the dark matter is what dominates the gravity inside the galaxy and sort of sets it spinning with the speed that it has.
All right, so we're talking here about the latest thing, which is mapping this stuff that we can't see. Sounds strange. How do you map it? What are they actually looking at?
Well, what they're looking at is actually the part that we can see. You know, you can see the light from galaxies that fill the universe. Our universe has over 100 billion galaxies. And so this new image has looked at about 2 million of those galaxies. And they've looked for slight distortions in the images caused by the fact that the light from those galaxies passed through more or less dark matter on its way to us.
Now, and that's done through this, describe the camera that I was referring to, a dark energy camera, excuse me, right?
It's confusingly called the dark energy camera. Yeah. It's not made of dark energy.
It's not perhaps the first confusion here, but let's stay with that one.
It's one of the confusions that we can clear up.
Okay.
There is this thing called dark energy. It's not matter, as you might guess. Dark matter, like we said, is actually kind of understandable. It's just some particle that we can't see, that's invisible but nevertheless gives rise to gravity. Dark energy is something that isn't even a particle. It's something that is intrinsic to space itself. It's some field of energy that is smoothly distributed throughout the universe and is pushing it apart. So the dark energy camera, its whole design purpose is to measure properties of the dark energy. But as a bonus, along the way, we get an unprecedentedly good map of where the dark matter is.
I like how you took us from the really understandable stuff to the completely obscure stuff, right?
But that's my job description. That's my expertise right there.
I appreciate that. All right, why is this important? I mean, why should the rest of us care about this?
Well, you know, the 1990s will go down in human history as the decade in which we figured out the inventory of the stuff from which the universe is made. 70% dark energy, 25% dark matter. Only 5% of the universe by mass is the ordinary stuff out of which you and I are made. So if you care about understanding the universe, 95% of it is dark matter and dark energy. If you want to know how the universe works, you have to understand that stuff.
And in terms of what's next, I know this map was just a very small, it's huge, it covers a lot of space, but still very small.
Well, what we're trying to do is to figure out more about the physics of the dark matter. You know, it's very annoying to us as scientists because we know it's there, we know how much of it is there, we know where it is, but we don't know what it is. We don't know what's actually making up the dark matter. So the more we can study its properties, how it collects, how it evolves over time, the more of a hope we get to understand what it is made out of and why there is dark matter at all.
All right, Sean Carroll, thank you so much.
Sure, my pleasure.
Iraq's Prime Minister Haider al-Abadi's visit to the U.S. came as the battle against the Islamic